how do you solve a math problem? So for example, 78.9 times 1.203 times 0.980. You probably said something like, put it in the calculator, write down whatever's on the screen, which would give you 93.018366. Is this the correct answer? So no, this would not be the correct answer because it's not always correct to report every digit the calculator gives you. And this is particularly important in science because you cannot just gain extra precision by just performing a calculation. So if we have a certain number of significant figures in each of our three measurements and we multiply all those measurements, our answer can't be more precise than what our three measurements were. And so what the real answer is, we want to put it in the calculator and write down the correct number of digits based on the rules of significant figures in calculations. So we will come back to this problem and show how to actually do this after we go through what these rules actually are. So just a little bit on rounding first. So when completing calculations, you'll have to round the numbers to the correct number of significant figures. The rules for rounding are as follows. If the first digit to be dropped is 4 or less, the digits are simply dropped off the numbers. So for example, if we have 4.2954 and we want to round it to the third decimal place, what we want to do is remove that 4. Because the 4 comes after that 5, that means we don't actually change that 5. And so the answer would just be 4.295. However, if the number that comes after the one that we want to drop is 5 or greater, then we have to round that digit up. So for instance, on this one, we want this 4 to be rounded up to 5. We want to drop that 5, and so that would give us the answer of 7.95. And so when multiplying or dividing measured numbers, the rule that we have for significant figures is that the answer that we have should have the same number of significant figures as the least precise number, or in other words, the number with the fewest number of significant figures. So for example, if we have 24.65 times 0.67, if we put that on our calculator, it'll give us 16.5155. But you cannot report 16.5155. How many significant figures does the above answer have? Well, it has 6 sig figs. But how many significant figures should the answer have? And so we want to look at the significant figures in the calculation. So the first one has 4 significant figures. The second one has 2. And so our answer should be to 2 significant figures. And so that means we should round it up to 17 since there is a 5 that comes after that last significant figure, a 5 that comes after that 6. And so if we go back to that question that we were looking at the beginning, we want to count these significant figures in each of these. So we have 3, 4, and 3. And so it looks like 3 is the fewest number. That means our answer should have 3 significant figures. But now when we're adding or subtracting, now we want to look at the number of decimal places. So we want our answer to have the fewest number of decimal places. So for instance, if we're adding 24.65 plus 0.617, the calculator would say 25.267, but we can't report 25.267 because this has 3 decimal places, where if we look at what we should have, we want to count how many decimal places each of the numbers we're adding together has. And the first one only has 2, the second one has 3, and that means our answer should only go to 2 decimal places. And so the take-home message for this is that when multiplying or dividing, your answer should have the same number of significant figures as the number with the fewest significant figures. And when adding or subtracting, your answer should have the same number of decimal places as the number with the fewest decimal places. And also, when multiplying and dividing, a good rule of thumb is that the number of significant figures that you will have in your answer will never increase, but will only ever decrease or stay the same. So when you're multiplying or dividing a bunch of numbers, your answer should never have more significant figures than anything that you were actually multiplying or dividing. It should only ever stay the same or decrease. When we're adding or subtracting, the number of digits after the decimal will only ever decrease or stay the same. It will never increase. But we can actually increase the overall number of significant figures because you can actually increase the number that you would have before the decimal place. And so here we have some practice problems. Again, I would encourage you to pause the video, look through these on your own, try to come up with the answers on your own before you watch the rest of the video where I am going to go through how to do these. So what you want to do for each of these is actually put these numbers into your calculator, and then in the second column here, we would want to write down what the answer is on the calculator. But then over in this last column, we would want to write down what the correct answer would be after applying our rules for significant figures. So I'll let you pause this and work through it on your own. And so for this first one, we have 93.0 divided by 0.285. And so if we put that in our calculator, we'll get this number. And so what we want to do to get the correct answer is look at how many significant figures each of the digits that we are actually dividing have, and both of them have 3. And so that means our answer should also have 3. So we want to take this number right here and just put it as the correct answer. Since the number that comes after that 6 is less than 5, that means we don't change that digit there. So for the next one, we are doing this 3.418 times 1903 times 0.9. If you put that in your calculator, you'll get this as your answer. And so what we want to do is count the significant figures in each of these. And what we see is that the one that has the fewest has 1 right there. And so that would just be that first digit right there. And so we look to the one that comes after that, which is an 8, which means that we have to round that 5 up to the next highest one. And so that would give us 6,000 as the correct answer. The next one, we are looking at 46.2 plus 12 minus 34.19. And so if we put that in the calculator, we'll get 24.01. So again, now we want to look at how many decimal places these have, because we are now looking at addition and subtraction. And so it looks like the one with the fewest number is 0 decimal places, and so that means our answer should have fewer. And so that means we want to just have this 24 here. The number that comes after the 4 is 0, and so the 4 will not change, so our correct answer would be 24. The next one, we are looking at this 43.6 multiplied by, then in parentheses, 2.194 plus 3.24. So if we put that in the calculator, we'll get this as our answer. So what we want to do is look at the number of significant figures here. So what we do is we can add the stuff in the parentheses first, and when we do that, we'll get something that has only 2 past the decimal. That's because the second number there, the 3.24, has only 2 past the decimal. And when we add those together, we'll get something that has 3 significant figures. We're multiplying by that first number, 43.6, which has 3 significant figures. That means our answer should be 3 significant figures. But we see that the number that comes after the 6 is 9, and so that means we have to round that 6 up to 7. And so that means the correct answer is 237. The next one is just multiplying 2 things that are in scientific notation, and so that means we can take just the coefficients for these as the number of significant figures. So if you put these in your calculator and multiply them, you'll get this as the answer. But to get the correct answer, we again want to add up all these things for the number of significant figures, and we see that the first one, the 4.25, is 3 significant figures. The 2.156 is 4 significant figures. And so that means our answer should be 3 significant figures. So that would be the 0.916 here. And the 3 that comes after the 6 tells us that the 6 does not change. And so the answer to this would just be 0.916. Anyway, that was everything for this video. In the next one, I will talk a bit about doing unit conversions, and I will see you then.